Welcome to Jeremy's IT Lab. This is a free complete course for the CCNA. If you like these videos, please subscribe to follow along with the series. Also, please like and leave a comment, and share the video to help spread this free series of videos. Thanks for your help. Also, remember to sign up via the link in the description to get all of the lab files for this course, so you can try it out yourself in Packet Tracer. If you want more labs like these, I highly recommend picking up Boson's NetSim for the CCNA. Click the link in the video description to check it out. It's a network simulator like Packet Tracer, but it's even better, and it includes all of these guided labs to not only help you get hands-on practice configuring and troubleshooting, but also deepen your understanding of the exam topics. I used it myself when studying for my certifications, so I feel confident about recommending it to all of you. If you want to get your own copy of NetSim, please follow the link in the video description. In today's video, we'll practice configuring standard ACLs, access control lists, with a little OSPF also. Standard ACLs can be used to identify traffic based on the source IP address of the packet, and then either permit or deny it. There are two main ways to configure them: standard numbered ACLs and standard named ACLs. In this lab, we'll practice both. So let's get right into it. Step 1 says to configure OSPF on R1 and R2 to allow full connectivity between the devices. We don't have to do any special OSPF configurations. Let's just simply enable it on each interface. I'll start on R1. Enable, conft, router OSPF 1. I'll enable it on the 2 gig Ethernet interfaces first. Network 172.16.0.0, 0.0.255.255, area 0. And now the serial interface. Network 203.0.113.0, 0.0.0.3, area 0. Let's see if it was enabled on each interface. Do show IP OSPF interface. Okay, we can see gigabit Ethernet 00, 01, and serial 000. So it's activated on all interfaces. Let's do the same on R2. Enable, conft, router OSPF 1. Again, I'll enable it on the 2 gig Ethernet interfaces first. Network 192.168.0.0, 0.0.255.255, area 0. And then the serial interface. Network 203.0.113.0, 0.0.0.3, area 0. And let's check. Do show IP OSPF interface. So we can see gigabit Ethernet 00, 01, and serial 000. Let's make sure they are OSPF neighbors. Do show IP OSPF neighbor. There's R1 in the full state. Notice the dash here. Because this is a serial connection, the OSPF network type is point-to-point, so no DR or BDR is needed. Finally, let's check the routing table. Do show IP route. R2 learned routes to 172.16.1.0/24 and 2.0/24 from R1. Perfect. How about on R1? Do show IP route. R1 learned routes to 192.168.1.0/24 and 2.0/24 from R2. So our OSPF configuration is working, and we now have full connectivity in this network. Now let's restrict some of that traffic according to the network policies in Step 2. 4 requirements are listed, and in this case, we should configure 1 ACL for each requirement. To get practice with both numbered and named ACLs, we will configure numbered ACLs on R1 and named ACLs on R2. As I said in the lecture video, ACL configuration can be quite flexible. So your configurations don't have to be exactly the same as mine. But here's my solution. The first 2 requirements are about restricting access to 192.168.1.0/24 and 2.0/24. Standard ACLs should be configured as close to the destination as possible. So we should configure these ACLs on R2. So let's return to R2 and configure that first one. only PC1 and PC3 can access 192.168.1.0/24. So I can make two permit entries, one each for PC1 and PC3, and then a deny any entry. The command to enter standard named ACL config mode is IP access list standard, and I'll name it 2_192.168.1.0/24. Now I'll permit PC1. Permit 172.16.1.1. And same for PC3. Permit 172.16.2.1. So, PC1 and PC3 are both permitted, and all other traffic will be denied because of the implicit deny at the end of all ACLs. However, a good practice is to put a deny any statement at the end anyway, just to make it clear. It's not necessary, but it's something I like to do. Okay, so the ACL has been created, but it's not doing anything yet. We still need to apply it to an interface. We want to restrict traffic entering 192.168.1.0/24, so I'll apply it outbound on G00. Interface G00, IP access group 2_192.168.1.0/24 out. Remember that the command to apply an ACL to an interface uses access group, not access list. Okay, let's test if it's working. For the sake of time, in this video I won't test every single requirement totally, but I still want to demonstrate a little. So I'll try a ping from PC1 to server 1. Ping 192.168.1.100. Because the ARP process needs to finish, the first ping or two might fail, but after that, we can see that PC1 is able to reach server 1. How about PC2? It shouldn't be able to reach server 1. Let's try a ping to server 1. Ping 192.168.1.100. So, 203.0.113.2, which is R2, tells us that server 1 is unreachable. PC2 has been blocked from accessing server 1. If we test the same from PC3 and PC4, we'd find that PC3 can reach server 1, but PC4 can't. Now let's move on to the next requirement. Hosts in 172.16.2.0/24 can't access 192.168.2.0/24. Again, let's configure an ACL on R2. IP access list standard, and I'll name it 2_192.168.2.0/24. So let's deny that subnet. Deny 172.16.2.0 0.0.0.255. However, we don't want to restrict any other traffic. So next, let's use a permit any entry to allow all other traffic. And finally, let's apply it to the interface. Interface G01, IP access group 2_192.168.2.0/24 out. Why this interface? Again, because standard ACLs should be applied as close to the destination as possible, and we are trying to control traffic destined for the 192.168.2.0/24 network. Now, I'll quickly test this ACL, first with a ping from PC1 to server 2. PC1 should be able to reach server 2. Let's see. Ping 192.168.2.100. Again, a ping or two might be lost until the ARP process finishes, but then PC1 will be able to ping server 2. But if we try from PC3, the ping should fail. Let's see. Ping 192.168.2.100. We get that same message. Destination host unreachable. Now I'll return to R2, and let's take a look at something I didn't show in the lecture video. Do show access lists. Here you can see each ACL, but you can also see how many packets matched each entry of each ACL, which can be very useful information. Okay, finally we have to use ACLs on R1 to stop the 172.16.1.0/24 and 2.0/24 subnets from communicating. So let's go to R1. I'll configure the two ACLs first, and then apply them to the appropriate interfaces. First up, I'll configure ACL1 to deny 172.16.1.0/24, but permit all other traffic. Remember, although named ACLs use the command IP access list, numbered ACLs just use access list. So, access list 1 deny 172.16.1.0 0.0.0.255. Then I'll permit all other traffic. Access list 1 permit any. That's it for ACL1. Now I'll just use the up arrow and edit this to ACL2 and make it deny 172.16.2.0/24. Then do the same for the permit any. And now I'll check. Do show access lists. Okay, ACL1 denies 172.16.1.0/24, but permits all other traffic. And ACL2 denies 172.16.2.0/24, but permits all other traffic. Now let's apply them. ACL1 to G01 and ACL2 to G00. Interface G01. IP access group 1 out. That restricts traffic from 172.16.1.0/24 from accessing 2.0/24. And next, interface G00, IP access group 2 out. That restricts traffic from 172.16.2.0/24 from accessing 1.0/24. Finally, let's test. I'll ping from PC1 to PC3. Let me show you something new. Here on PC1, I'll use the command ping-t followed by PC3's IP address, 172.16.2.1. This tells PC1 to ping forever until we stop it. You can stop it with Control-C, but I'll leave it for now. Notice that PC1 can't reach PC3. Now I'll do the same from PC3 to PC1. Ping-t 172.16.1.1. Again, PC3 can't reach PC1. Now I'll go back on R1 and let's check those ACLs. Do show access lists. Notice how many matches there are for the deny entries, because all of those pings between PC1 and PC3 are being blocked. If I use the up arrow to repeat the command, you can see the count keeps going up. Okay, in this video, we did some basic OSPF configurations to allow full connectivity in the network, and then use standard ACLs to restrict specific traffic. That's all for this lab. Now let's take a look at a lab in Boson NetSim for CCNA. Okay, here's today's Boson NetSim lab preview. Now NetSim for CCNA actually has quite a few labs for ACLs. Here in the Security Fundamental section of NetSim for CCNA, I counted 20 labs for ACLs. That's right, 20. So if you're getting ready for the CCNA exam and you want to practice labbing ACLs, you got to get NetSim. If you complete all of these practice labs in NetSim for ACLs, you're set for the CCNA exam. You don't need to know anything more about ACLs. Okay, so the one I've chosen to show you today is ACL Practice Lab 2, Standard ACLs. So the objective is practice configuring standard ACLs on Cisco routers. Pretty simple. Here's the topology. Router 1 with switch 1 and PC 1 in VLAN 1, and then router 2 with switch 2 and 3, PC 2 and PC 3 in VLAN 2 and VLAN 3. And here are the commands you need to know. So in this lab, we are configuring standard numbered ACLs with this command. Okay, here are the IP addresses on each device. Each of the routers has a loopback interface. And router 2 is using router on a stick. You can see the sub-interfaces here for inter-VLAN routing between VLAN 2 and VLAN 3. Okay, here are the lab tasks. Task 1, I think task 1 is the only task. Yes, it is. Practice configuring standard ACLs. Okay, so you can read this little introduction here. Just notice the passwords are configured as Boson. Okay, so from each PC, verify that you can ping the loopback 0 interface addresses of router 1 and router 2. So if you look at these log messages here, you can see that OSPF is configured on the routers. So hopefully these PCs can ping those interfaces. First on PC 1, here's router 1's loopback. Okay, it works. I hit, this is Control C to cancel that ping. And router 2's loopback. That works. Next, PC 2. Okay, looks good. And that works as well. And finally on PC 3. Okay, and last, router 2's loopback. That works as well. Okay, from each PC, verify that you can ping every other PC in the topology. Okay, just for the sake of time, I'm not going to do that. Let me just check the routes here on the routers. So, router 1 has routes to 10.0.2.0, which is VLAN 2, and 10.0.3.0, which is VLAN 3. And also VLAN 1 is directly connected. Let's check the routes on router 2. Show IP route. And it learned from OSPF a route to VLAN 1, and it has a route to VLAN 2 and VLAN 3. Okay, next step 3. From each PC, verify that you can telnet to router 1's loopback 0 interface. Okay, telnet is something we haven't looked at yet, but it's a way of connecting to a device, like a router or switch, to configure it in the CLI. So telnet to router 1, and it works. So now you can see I'm in PC 1, but I've connected to router 1, and I can configure it just like I was connected to the console of router 1. But I'm going to exit out of there. Okay, on PC 2, I'll try the same thing. Telnet 1.1.1.1. Enter the password, and I'm connected to router 1. So I will make a video about telnet later in the course, so don't worry about it for now. Okay, in PC 3, let's see if we can connect to router 1. Okay, looks good. All right, and I'll exit out of there. Okay, so step 4, create standard ACL 1 and configure it to deny traffic from VLAN 2 and VLAN 3. All other traffic sources from router 2 should be permitted. Use no more than 2 rules when configuring ACL 1. Okay, ACL 1, let me see where I have to apply it. Apply standard ACL 1 to the correct interface and in a direction that will prevent traffic from VLAN 2 and VLAN 3 from accessing any of the networks on router 1. Okay, so let's think about that. So on router 1, we want to prevent PC2 and PC3 from connecting to any of these networks, either VLAN 1 here or the loopback interface on router 1. So I think we should configure the ACL on router 1 and apply it inbound on this interface. So when traffic tries to come to router 1 from router 2 from these PCs, it will be blocked. Okay, so deny traffic from VLAN 2 and VLAN 3. So let's configure that. Conf T access list 1 deny 10.10.2.0. And for the wildcard mask, I'm going to use a wildcard mask that includes VLAN 2 and VLAN 3. O.O.1.255. And I hope I'm correct about that. So this should cover 10.10.2.0 and 10.10.3.0/24. And then I will create a permit statement. Access list 1, permit any. Because it only says to block traffic from VLAN 2 and VLAN 3. It doesn't say anything about other traffic, so we should permit it. Okay, apply standard ACL 1 to the correct interface and in a direction that will prevent traffic. Okay, so I'll apply that to, what was that interface? It is this one here, Fast Ethernet 00 is the one connected to router 2. IP access group 1 in. Okay, and then we will try to telnet and ping router 1's loopback 0 interface. So from PC1, both should work. Okay, so that works. I connect it to router 1 and I'll ping it. And that works as well. Now from PC2 and PC3, if our ACL is configured correctly, this should not work. Yes, so that didn't work. It says trying 1.1.1.1, but then it just returned us to the command prompt. So that didn't work. How about a ping? Destination host unreachable. Okay. Next, I'll try from PC3. Telnet 1.1.1.1. Okay, same thing, doesn't work. Ping 1.1.1.1. Destination host unreachable. Perfect. Okay, next, step 8, create standard ACL2 and configure it to deny traffic from VLAN 1. All other traffic sources should be permitted. Use no more than 2 rules, okay. And apply standard ACL2 to an interface and in a direction that will prevent remote networks from pretending to reside on VLAN 1. Okay, prevent remote networks from pretending to reside on VLAN 1. Let me briefly explain that. So let's say there's a PC here in VLAN 2 that modifies its source IP address. Or it doesn't have to be here. It could be connected somewhere else, maybe out here on the internet, connected to router 2. And it wants to access something in VLAN 1, let's say PC1. So it sends a ping to router 1, and the source is in VLAN 1, and the destination is in VLAN 1. It forwards it to PC1 like normal. However, if we place an ACL outbound on this interface, I believe it's Fast Ethernet 10, blocking all traffic with a source in VLAN 1 from exiting that interface, it will prevent that. So, traffic from VLAN 1 will still be able to exit, but because we applied it outbound on this interface, that traffic pretending to be in VLAN 1 won't be able to enter. So this is a security measure. I will talk more about security later in the course, so don't worry if you don't understand it perfectly right at the moment. So let's configure that here on router 1. Access list 2 deny 10.10.1.0/24 and permit other traffic. Oops, I forgot this is not a named ACL. Access list 2 permit any. And then I will apply it to that interface outbound here, Fast Ethernet 10. IP access group 2 out. Okay, display and examine the rules you created for both ACL1 and ACL2. So I'll do that with do show access lists. And there they are. As you can see, we've already got some matches for ACL1 when we tested that telnet and ping. Okay, based on what you have configured so far, apply either ACL1 or ACL2 to an interface and in a direction that will prevent hosts connected to router 1 from pretending to be hosts on VLAN 2 or VLAN 3. Okay, so that is the same principle as before. So ACL1 matches these source addresses. So because they are the source, all the traffic should be entering this interface. No traffic with that source should be exiting this interface. So I'll apply the ACL outbound on this interface, Fast Ethernet 00. Yes, that is correct. Okay, interface F00, IP access group 1 out. Okay, and that is all for the lab. So I will use the grade lab function. Click on this icon and let's see if we got it correct. Okay, that is correct. You completed the lab successfully. So you can check the configuration of each device. Nothing is highlighted, so that means I did it correctly. Okay, so there's a lab from Boson NetSim. Fairly simple, but also some challenging parts in it. So that's the thing I like about NetSim. Some of the labs are pretty simple, some of them are more complex, and some of them are a mix of both. There are, as I said before, 20 labs for ACLs here, so you get quite a variety of practice for access control lists. If you want to get Boson NetSim, please follow the link in the video description. Before finishing today's video, I want to thank my JCNP level channel members. To join, please click the Join button under the video. Thank you to Junhong, OJ, Magrathia, The Gun Guy, L33 America, Unjabulo, Benjamin, Tsepiso, Justin, Prakash, Nasir, Erlison, Apogee, Marco, Flodo, Daming, Joshua, Gilmar, Ed, Value, John, Funny Dart, Scott, Hassan, Marek, Velvajacum, C-Mode, Mark, Yusuf, CD, Boson Software, Devin, Lito, Jonathan, and Vance. Sorry if I pronounced your name incorrectly, but thank you so much for your support. This is the list of JCNP level members at the time of recording, by the way, November 23rd, 2020. If you signed up recently and your name isn't on here, don't worry. You'll be in future videos. Thank you for watching. Please subscribe to the channel, like the video, leave a comment, and share the video with anyone else studying for the CCNA. If you want to leave a tip, check the links in the description. I'm also a Brave verified publisher and accept BAT or Basic Attention Token tips via the Brave browser. That's all for now.